Hi, I'm Mary Beth Gilliam, and this is the Outperform Cancer podcast, where we discuss actionable anti-cancer strategies found in peer-reviewed scientific research. I'm joined today by Dr. Jed Fahey, known by many as the leading expert on sulforaphane. What is sulforaphane, you may ask? It is a powerful phytonutrient found in some cruciferous vegetables, most notably broccoli, with up to 100 times the potency in broccoli sprouts. Cancer patients may have heard about phytochemicals because of research studying their impact on cancer cells, the tumor microenvironment, and the multiple pathways cancer uses to grow and metastasize. There are 5 phytochemicals known in cancer circles as the big 5 because of their cancer-fighting properties. They are curcumin, which is found in the turmeric plant, resveratrol, found in purplish fruits like red grapes and blueberries, genistein, which is found in soybeans, and EGCG, found in green tea. The last one is sulforaphane, one of the big 5. So before we go further, I want to make sure you're not fooled into thinking that just because these phytochemicals are found in plants, that they're not important. Roughly 25 to 40% of prescription drugs are either directly derived from plants or synthetic versions of plant compounds or designed based on plant chemistry scaffolds or structures. And in oncology and infectious diseases, that percentage has historically been even higher. In fact, I've found research suggesting about 60% of oncopharmaceuticals in clinical use have been designed based on plant compounds, and more than 60% of highly effective anti-cancer drugs are from plants, aquatic organisms, or microorganisms. An example of that is paclitaxel, sometimes just called Taxol for short. That comes from the Pacific yew tree. And everolimus, another breast cancer drug and drug that has other uses as well, comes from rapamycin, which comes from soil bacteria, first found on Easter Island. So plants are master chemists. They've been running evolutionary drug discovery for hundreds of millions of years. So if you're thinking, what impact could a little broccoli sprout possibly have on my cancer? The answer is perhaps a big one. Sulforaphane's been researched for decades, and recently there's been an explosion of interest in it. A 2021 review of research papers on sulforaphane's anti-cancer effects reported 192 preclinical studies, that's studies with cell cultures and animal models, plus 19 clinical studies on sulforaphane or its precursor called glucoraphanin. And in 2023, an article in a highly regarded journal, Frontiers in Oncology, titled Anti-Cancer Properties of Sulforaphane, Current Insights at the Molecular Level, states up front in its abstract, quote, "This paper concludes that sulforaphane provides cancer protection through the alteration of various epigenetic and non-epigenetic pathways. It is a potent anti-cancer phytochemical that is safe to consume with minimal side effects." Boom. What a quote. I'm going to keep going on. The journal Cancer, another great reputable journal, included an article in 2024 titled Harnessing Sulforaphane Potential as a Chemosensitizing Agent, a comprehensive review. Listen to this. Notably, sulforaphane, an isocyanate derived from cruciferous vegetables, including broccoli and cabbage, has exhibited potent chemosensitizing capabilities across diverse cancer types of bone, brain, breast, lung, skin, etc. Chemosensitization refers to the enhancement of cancer cell sensitivity to chemotherapy agents. counteracting the chemo resistance often developed by tumor cells. It goes on to say, this review illuminates the multifaceted role of this phytochemical, emphasizing its potential to enhance the therapeutic efficacy of anti-cancer agents, suggesting its prospective contributions to cancer chemosensitization and management. I got to give you one more, but these are on and on and on. There's so many of them, but here's one more I got to share with you. Here's another study from a 2024 journal called Molecular Medicine. Again, highly rated. The journal article is called Potential Mechanisms of Cancer Prevention and Treatment by Sulforaphane, a natural small molecule compound of plant-derived. Quote, therefore, the application of sulforaphane is expected to be a necessary new approach to treating cancer. In this paper, we review the multiple molecular mechanisms of sulforaphane in cancer prevention and treatment in recent years, which can provide a new vision for cancer treatment. I'm telling you, I could go on and on, but I know you want to hear from the expert, Dr. Jed Fahey. Dr. Fahey is a nutritional biochemist with an extensive background in plant physiology, human nutrition, phytochemistry, and nutritional biochemistry. He spent 27 years as a faculty member at the Johns Hopkins School of Medicine, and until retiring in 2020, he ran the Coleman Chemoprotection Center, which he helped create, which has for many years developed plant-based agents for the purpose of enhancing lifespan. Join me in welcoming Dr. Jed Fahey. Thank you for coming today, Dr. Fahey. We're really excited to talk to you.
Thanks for having me. I'm looking forward to enlighten them on a few things that you and I are passionate about.
Yeah, absolutely. I want to jump right into almost the middle, which is getting to the point of why should cancer patients care about sulforaphane? Because I know that that's on the top of everyone's head. What is this? It's a big word. Some people might not have heard of it. So can you give a summary of your excitement about sulforaphane and its ability to positively affect cancer patients?
Yeah, I mean, we got interested in it. My mentor, Paul Talalay, was a cancer physician, a cancer biologist, and he got into it and pulled me in very quickly in the early 90s because the epidemiologic evidence going back into the 1970s was suggesting very strongly that cruciferous vegetables in particular were protective against certain types of cancer. From that, our group at Johns Hopkins Medical School started looking at a variety of fruits and vegetables for their protective effects in an established cell culture model. And it turns out that, no surprise in hindsight, but cruciferous vegetables were the best in inducing this protective response. Then Yushin Zhang, then a medical student of Paul's, and Paul discovered sulforaphane in broccoli, very small amounts. Then I came along and discovered that actually it was not sulforaphane itself, but it was its precursor, glucoraphanin, in broccoli that was potent, and that broccoli sprouts were far more potent and had far more of it. So that was 1993, 94, 95. And from then on, we've been sort of maniacally focused on sulforaphane until I retired from Hopkins in 2020. So it was protective in cell culture. And over the years, focusing almost exclusively on cancer models initially for the first certainly 10 or 15 years of our work, it was protective against a variety of cancer cell lines and in a variety of animal studies, cancer studies, breast cancer and so on. And of course, many other people picked up the charge and had other models, in particular, other animal models. Sulforaphane comes from food, and it comes from broccoli or broccoli sprouts. So it's very easy to give it to people. Um, Ethically, it's very easy to have people eat, high doses of broccoli or broccoli sprouts or a hot water extract of them. And what we designed to do at that time was to keep that dose within the range that the epidemiologic studies said enthusiastic broccoli eaters would get.
Okay.
Um, okay, but the key is that we characterize the amount of sulforaphane available from such and such an amount of broccoli or broccoli sprouts or from the hot water extract. So it's not a drug. It was never a drug, and it still is not a drug.
Mhm.
It's been put into supplements, but again, it's not a drug. It's a supplement. We can talk about that later.
Mhm.
So over now, 30 plus years, the evidence has just snowballed. There are hundreds and hundreds of publications each year about sulforaphane, looking at it in every conceivable type of cancer, as well as a variety of other chronic non-communicative diseases, as well as, in fact, some infections. And I don't want to give the impression that it's a panacea and a cure-all. It isn't. But what we've found mechanistically, we and many others now around the world, is that it intersects, if you will, a variety of regulatory pathways. And in some cases, it downregulates them or dampens them, things like inflammation. And in some cases, it upregulates them or boosts them or elevates them. And the biggest example of that, and probably the most important, is the so-called NRF2 or NRF2 pathway, which is a major cell detoxification pathway, an antioxidant pathway. And it's present in pretty much all cells of the body, not just the liver, which is sort of the classic place for detoxification.
Mhm.
But since sulforaphane actually goes to the brain and crosses the blood-brain barrier, we even find that it acts directly in the brain in terms of detoxifying.
Wow.
So therefore,
Yeah.
sulforaphane is an absolute world-class molecule for prevention of a variety of cancers. Again, we can talk about them later, as well as a variety of NCDs, non-communicable diseases, chronic diseases like probably diabetes, cardiovascular disease, and on, because it helps boost this detoxification and antioxidant system. How does it work with therapy and cure? Well, we have to walk a little more carefully there, because as opposed to the prevention trials, and there are now about 125 clinical studies looking at sulforaphane in human beings, and not just rats and mice and cell cultures. When you look at cancer treatment, as you well understand, the ethics of these trials is, well, the ethics is the same, but the way you do these trials is much, much different. And you must have people on standard of care before you start asking questions of phytochemicals or foods. It just makes it a much more difficult to do those clinical studies, extremely difficult, very expensive, and frankly, the drug companies
Mm.
are not interested in supporting those trials because they have their cancer therapeutic drugs. Gee, what if a food or a supplement made people either not require those drugs or require less?
Well, I'd like to just pick apart a few things and get you to explain a little bit more. First of all, you mentioned dosing, and you mentioned that, the initial discovery was broccoli or cruciferous vegetables, and then broccoli, and then you discovered the power of broccoli sprouts. Can you just tell us a little bit about the dynamic of what you're seeing in the lab? Are you seeing a consistent pattern where if there's an increased exposure, you see increased benefit. What is the dose that you are seeing in most of the research studies?
Yes. So to put in a little bit more sciencey manner, there is very definitely a dose response effect. So more gives a higher response. Obviously, as with anything, be it drugs or nutrients or supplements, there's a peak, and there's a point at which you start bleeding into toxicity. Um, but there's absolutely a dose response curve. What we attempted to do in our clinical studies, and everybody has attempted to do, is to keep the range of sulforaphane delivery within that, as I said, an enthusiastic broccoli eater would get. So there's so much epidemiology now there on diet, and the NHANES studies and nurses' health and physicians' health study, so many of them, large cohorts in this country and elsewhere, that characterize food consumption. And so we could probably, with some wobble in the numbers, tell you, what the top 1% of sulforaphane intake is in the world, just based on self-reported cruciferous vegetable consumption, broccoli in particular.
Mhm.
So anyway, we try to stay within a reasonable range, that which someone the people in the top decile or the top 10% of broccoli eaters would get.
I just want to stop you for a minute because toxic dose, I don't believe that toxic means you're going to die from it. I think what you're saying is toxic might maybe make your stomach upset or something. Is that true?
Toxic is I'd say is the next step beyond making your stomach upset. Plenty of people get their stomach upset from eating, a variety of foods, including broccoli, cruciferous vegetables. So gas and bloating and belching are they get fairly common with higher doses of things like broccoli or beans,
Hmm.
or on and on. No, toxicity is more, there's an effect on some of the blood biomarkers that you don't want to see, or
Okay.
the liver toxicity, common panels that a physician looks at.
So you
Um,
could really, I mean, if you were eating, you must have to eat a ton of broccoli. You could make yourself sick theoretically.
Well, the thing I love about these kinds of trials with food or food products is if we're talking about eating a vegetable, it's auto-limiting, it's self-limiting, because you'll make yourself sick if you try to survive on broccoli alone, for example, or broccoli sprouts. It won't happen. That trial won't happen
Mm-hmm.
because people will stop.
Okay.
So there's a practical and realistic limit.
Mm-hmm.
An argument you could make about supplements, though, is when dietary supplements concentrate phytochemicals, or whatever they concentrate, then theoretically you could have people taking too much.
Yeah.
So there is some risk of overdosing with supplements, as there is with drugs, which
Yeah.
is why there needs to be more scrutiny on those sorts of clinical trials. But let me tell you, the trial that I really would like to see, and I can tell you why it's not being done so far, is a dose escalation trial of a sulforaphane supplement, something that contains sulforaphane or glucoraphanin in the precursor, um, in people. A dose escalation trial that really explores the upper limits of things. What happens with clinical trials of the sort that we've been involved with for a long time is someone does a trial with a certain dose, calculated the way we did based on epidemiology, and they get a positive result. Right? So then they do a follow-up trial, or someone else gets funding to do a follow-up trial or a somewhat different trial. But what dose do they use? Well, you think about it, there's a big grant riding on this. These trials cost a lot of money. The temptation or the tendency is to use the same dose that first group used,
Right.
or to at least be close to that, perhaps use multiple doses. but not to stray too far from it because you want a successful trial. You
Sure.
want to see positive results. That's a bias. Um, so it turns out that the range of dosing has been fairly concentrated in all these 125 trials, with some exploring higher doses, certainly. But to do a pharmacodynamic study where you're looking at effect, you're looking at side effects, you're looking at that threshold of toxicity
Mhm.
with in escalating doses in the same people would be really, really helpful.
Yeah,
Again, the ethics come in because what happens if you start to see a toxic effect? You immediately have to stop,
sure.
um, and you should.
Yeah.
But we haven't approached that upper limit yet, I think, except with vegetable consumption. And that's, again, going back to you just can't eat too much broccoli. You get grossed out.
So let's just break that down for like a cancer patient per se, because there are supplements on the market for sulforaphane. And on my supplement bottle, it will tell me, here's the dose. Is the dose that's on a supplement bottle similar to the dose they saw having efficacy in those studies? Is that fairly consistent?
I would say the dose recommended on supplement bottles is very conservative. And for two reasons. One has to do with the economics of things.
Mm-hmm.
Cost of goods for these supplement makers is what it is. Having co-founded and now consulting for a company that makes the raw ingredient, Nebraska Protection Products makes something called True Brock, which is a broccoli seed extract rich in glucoraphanin. And I've been involved with the quality control and the testing of that product for years and years and years. I know on their website, the company's website, they indicate that the supplements into which it goes. They don't sell the supplement themselves. They sell to many of the big supplement makers. So I know a little bit about the costs involved in procuring raw ingredients. So that's one reason I think they're conservative on dose. The second reason is I think they're giving a rather low range. Usually for glucoraphanin, it's about 30 milligrams in many of these tablets for reasons of, they don't want to be liable when people, as I was talking about a few minutes ago, if someone says, oh, I'm feeling sick today, I need more vitamin C, I'll take 3 grams, or I'm going to take some more sulforaphane supplement.
Right. Then
I
you don't want
think
them
that,
to overdo, so they don't give each pill too high of a dose, I think is what you're saying.
I
And I
suspect that's what's happening, but I don't know.
and
Yeah,
then
yeah,
conservative, when you say conservative, meaning that it's on the lower side. So each pill
yeah,
is on the lower side, that keeps profits up, among other things. Maybe helps
yeah.
from, helps us to help ourselves and make sure that we don't overdo. What I just want to close the door on is connecting the dots back to levels that you've used in the lab. And I understand it's different for people with mice, and I understand it's different when you translate with the epidemiology studies. And to your point, we haven't had a really good research study that's shown the levels of dosing. I guess the only thing I'm wondering as a patient myself, and as someone who actually takes a sulforaphane supplement myself, just wondering how that current conservative dose relates to the research. Is there anything you can tell us specifically about that, 30 milligram level approximately?
Yeah. So both in 2019 and in 2021, we assimilated all the clinical trials that had been done to date. There were something like 75 or so then. Now there are over 125 with sulforaphane. And we have a beautiful, in my opinion, graph that shows all of the doses and highlights with green dots the ones that were efficacious or
Okay.
effective in these trials. Um, and the answer to your question is 30 milligrams, which is in many of the supplements, is a little bit on the low side. I think the sweet spot in the graph that I'm telling you about was more in the 50 to 100 milligrams of glucoraphanin range.
Okay.
And in broccoli or broccoli sprouts, there's a precursor compound that's very stable called glucoraphanin. It is converted by an enzyme in the body. Well, it's in your microbiome, in your bugs in your gut. It's converted to something called sulforaphane. And sulforaphane is the one where all the action happens. That's the active molecule. So I tend to use the terms interchangeably, but in supplements, we want to deliver glucoraphanin because it's stable, and it is converted to sulforaphane either in the body or if you add the enzyme responsible for that conversion to the supplement, which can be done in a lot of these cases.
And so, is it readily bioavailable? Because I know with a lot of supplements, that has been a problem where, you can take a lot of it, but it's just not getting where it needs to go. Is this bioavailable?
Sulforaphane is extremely bioavailable. Yes, sulforaphane itself. So you do have to undergo this conversion from the precursor glucoraphanin to sulforaphane. And if you give the supplement with the enzyme, the active enzyme, it's called myrosinase. We know, in fact, we have a paper that'll be published any day now. We know that the conversion happens up higher in the digestive tract, the small intestine, and sulforaphane is made available more quickly. If you don't give the enzyme, you're relying almost exclusively on the body's bacteria, the gut bacteria. So the conversion and absorption doesn't happen until you get down to the large intestine.
You're known as the broccoli sprouts guy. You've done some amazing interviews over the past years about broccoli sprouts. So if you eat sprouts, which I have in my kitchen every day, growing my own sprouts in addition to the other sulforaphane that I take. So I grow my own sprouts. When I eat those sprouts, they have both in them, right? So when I'm eating them, I'm actually getting the glucoraphanin and the myrosinase, and that's in much higher levels than broccoli. Is that correct?
That's absolutely correct. It was such a setup for me that I appreciate it. Yes, you're absolutely correct. Look, you started or we started the conversation on supplements, and we hadn't talked about broccoli sprouts. I don't know what percentage of the population eats broccoli in this country, for example. It's certainly not 100%. I don't know what percentage eats sprouts, but it's far lower than the amount who eat broccoli. So sprouts are becoming more popular again. I would love to see everybody eat broccoli sprouts because you're absolutely correct. That is the ideal way to get both the enzyme and the precursor glucoraphanin.
And it's
And
cheap.
and it's cheap. And it not only is it cheap, but you get the fiber, you get all the other nutrients, you get whatever synergies go along with, the different flavonoids and other phytochemicals, and there are thousands of them in broccoli sprouts. You get all of that. You get to replace Doritos and Coca-Cola with something more nutritious, so you won't eat as much garbage, because they're filling. Yes, I mean absolutely. It's
And
just that we know there are a lot of people who don't. And I also have not one but two jars of sprouts going on my kitchen counter at almost all times.
yeah.
They're there now, and I eat them probably 4 or 5 times a week. Sometimes just as a big bowl of sprouts with a bunch of stuff. The
Yeah.
sprouts aren't the garnish; they're the main course.
Wow,
Um,
that's pretty amazing. And I do know that you had said sprouts can be frozen and they won't lose their efficacy. So, a lot of times I might be traveling or something, and you grow these sprouts, and you got to be careful that they don't get moldy, that they don't hang around too long. And so I just tend to grow them. I throw them in a Ziploc, I put it in my freezer, and then I use it for smoothies. I just make a smoothie with it, and then if it's too bitter of a taste for you, you can throw some blueberries or some fruit in there, and it offsets that flavor. I actually remember a study that has mango connected with it, and it had a nice flavor profile mix with the sulforaphane, if I remember correctly.
Yeah, I do the same thing, Mary Beth. I have in our freezer in the garage, I have some bags of frozen sprouts that I overproduced, or we were expecting company and they didn't show up and I had too many sprouts. I actually am a scientific advisor for a company called the Sprouting Company that makes sprouting just so much easier than the only people in the world that I'm aware of. They sell high glucoraphanin broccoli seeds. If you're after your sprouts, not just because you love the taste of broccoli sprouts, but you want a particular, you want to know you have a dose of glucoraphanin or sulforaphane. Um, they are selling them now. They just started, I don't know, 6 months ago or so. But
So I just want to
uh,
capture that for patients. Where do they go for these high glucoraphanin broccoli seeds? I'd like to know.
oh, okay. It's called the Sprouting Company.
Okay.
Yeah, and actually, Doug Evans, the guy who started the company, wrote a book called The Sprouting Book or something like that, which is a wonderful little book with a bunch of recipes and discussions about how to sprout. But then after that, he came out with this. I won't call it a machine. It's just a device. It puts the bottle on an incline. It's straight, so you don't get sprouts caught up in the neck. It has a wonderful screen. Um, so yeah,
Nice.
it's called the Sprouting Company, and it's online, and yeah, yeah.
That's
So,
fantastic. It's good to,
so
it's good for people to know like how to take this knowledge and put it into action. This
yeah,
stuff isn't hard, everyone. And I do want you to know that on my website at outperformcancer.com is links to how to grow sprouts. Jed and I have spoken, but really I've taken from his work with Dr. Rhonda Patrick, who spent a lot of time on, just how to videos on how to grow sprouts safely. So go to my website if you want to look at that. Sorry, Jed, back to you.
oh, that's fine. I have done a little bit simpler one too, with a group called Vitamin and Me, and the Sprouting Company has some how-to videos. The thing I'd encourage people to do is if they're clean the
Mhm.
seeds before you start sprouting. There's debate out there about whether you need to, but I opt for just adding a little Clorox in water for 10 minutes and rinsing the seeds before I soak them and then sprout them.
Yeah, that always freaks me out. I gotta say, the idea of putting Clorox in them, but I know you've said that that's safe.
I absolutely opt for Clorox. It's proven, and you rinse it. You just have to rinse, 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 rinse. So
Okay.
after you and you rinse it away, and the seeds are essentially dead to the world at the time you're doing that. And it's only after you've soaked them then for a half a day or 8 hours that they start to metabolize and absorb things.
Oh,
So
okay.
none of that Clorox is going in the seed.
Good to
You know,
know.
you mentioned smoothies. You're younger than me, and so you're maybe of the smoothie generation, but I just I never grew up doing smoothies. So I tend to like consuming my sprouts as just as the sprouts, but there,
Straight up.
plenty of people don't like the texture. So in that case, go for it with smoothies. Yeah, yeah.
We talked about how broccoli sprouts is a much lower cost alternative to having a supplement. And I want to make 2 points. One is there is a range of cost in the supplements, and there's some that are as high as like $60 for a bottle. I have found plenty that are in that $25 range that are just as efficacious, that use the same True Brock supplement early form that you were talking about. So I encourage people to look. Expensive is not always better. Sometimes it's just more expensive. The other thing I want to do is to talk about the cost of healthcare briefly. Cancer costs are through the roof, and everybody's been talking recently about what are we going to do about this extreme cost of healthcare. There are several research studies that have quoted the cost of when someone is diagnosed with cancer. I found an article from 2023 in Current Oncology suggesting the cost of a case of late stage cancer in the US is about $516,000. And an earlier article from 2020 in AACR's Cancer Epidemiology, Biomarkers and Prevention suggests the cost is about 60 to 100,000 per patient per year. Now, let's let's factor in research from American Cancer Society and others that found that 40% of all cancers are estimated to be preventable, and about 44% of all cancer deaths can be preventable. When you mix all of that up in my brain, it makes me just go, wow. I'm wondering if we can think about, your evidence and the work that you've done and prevention and what you've found in your epidemiology research and research of others that suggests that maybe we can make a dent in this thing before anyone even has cancer so that we're not struggling with this, and think about the cost savings that that would create. Can you talk about some of the leading epidemiology studies and what those found?
Sure. And you know, indeed, the whole reason we got into this business, if you will, as academics, um, uh, is the idea of prevention. I mean, as I told you earlier, uh, Paul Talay and I thought in our, infinite wisdom that broccoli sprouts would be a good thing to get out to people as a preventive, as a cancer preventive. That was our sole focus back then. And I published with my colleague Tom Kensler a paper in 2013, I think it was, in the American Medical Association's Virtual Mentor. We cited some figures of the cost of prevention, and we tried to estimate, our best guess of what it would cost for a diet-based prevention strategy. And that's a hard one to put a number on, but we had some help doing that. We had some other numbers. And then we as I recall, we contrasted that. I don't have the paper in front of me. We contrasted that with, the cost per life saved of the seatbelt, mandatory seatbelt laws, and a number of other very commonly known preventive strategies. And a dietary approach to cancer prevention was way, way down on the list in terms of its cost, however you quantify it, cost per life saved, cost per year of uh, uh, what's it, quality, what's the metric that epidemiologists used? Qualities,
Quality life years saved or something like that?
yeah, yeah, yeah. So anyway, it's, I think, very convincing that a dietary prevention strategy could be very effective against cancer. In the intervening years, since we started thinking about it, of course, exercise is the other huge factor.
Yeah, of course.
And the whole, I don't need to, you've done a great job of calling attention to a number of factors which can be prevented. But as you say, the numbers on the percentage of uh, cancers that are estimated to be preventable by a dietary approach have hovered between 30 and 45% for decades and decades. I
Mm.
mean, really, before we started becoming interested in it.
Did
But
you do some research in China about this?
well, we did some clinical work on it.
Okay.
Yeah, we did some clinical work. But anyway, the point is that with sulforaphane in particular, over the years, over the decades now, since one can add not only prevention of cancer, but prevention of uh, or reduction of the harm or the risk of things like diabetes and cardiovascular disease and many others actually, that the economics look even more impressive for prevention. And as I told you before we started this podcast, you and I need to we need to write an article with the most current numbers and talk about it, but that's on the list.
It's on the list.
Um, yeah. So you asked about our work in China. Yes, we did number of studies in which we looked at the protective effects of a broccoli sprout extract rich in glucoraphanin and sulforaphane on air pollution. And projecting that to the epidemiology, we know that air pollution causes hundreds of thousands of, if not more, cases of lung cancer a year. So does cigarette smoking. Who's at risk? Well, certainly smokers, certainly side stream smoke. Firefighters is a big one. There may actually be some epidemiology on that. People who live near highways, people in congested areas, people more in the north of China than in the south because they use more coal to heat with in China. And there's, as we know, there has been a lot of air pollution there. So those are the kinds of things that we were thinking of when we did our study. And yes, we found that sulforaphane was elevated the protective enzymes, the so-called NRF2 pathway, as evidenced by what we found in the blood and urine and when we took these samples into the lab. Could we prove that we saved lives with it? No. That's part of the problem with prevention research, right?
Right.
If you're looking at preventing a disease that someone doesn't yet have, what's the denominator? What's the numerator for that matter? It's very, very difficult to prove.
Mm-hmm. Yeah, it's a difficult thing to do to try to figure out. You need long, big studies in order to be powered enough to really see the difference. But I was just looking up, yeah, there is, tons of research that clearly links air pollution with lung cancer risk, for example, but even beyond lung cancer, just to cancer in general, with mechanisms of action, including oxidative stress, chronic inflammation, DNA damage. And those things, oxidative stress, chronic inflammation, and DNA damage, I know are all things that you've talked about that sulforaphane impacts. Is that true?
Yes, it is true.
Yeah.
Yeah.
So there's a lot of potential in driving down costs and improving our lives and hopefully preventing cancer for many people. I think circling back to some of the power that sulforaphane has that you've identified, there's real underlying mechanisms at play here that make sense.
Let me take you back to the very first epidemiologic study on cruciferous vegetable consumption that I'm aware of or I've cited frequently, and that was in 1978. And this was a study looking at the effects of cruciferous vegetable consumption on colorectal cancer. And there was a dose-dependent effect. So this was all using, epidemiologic data, people being queried about how much of everything they ate. And so the more cruciferous vegetables people ate, the lower their risk of colon cancer. And it was so striking that if you plotted those risks out, you came up with the fact that 2 servings a day of cruciferous vegetables equated to a 50% reduction in the risk of colorectal cancer.
Wow.
50%. So having the risk just by eating freaking veggies,
That's
the right ones.
amazing. Just as a frame of reference, so I have a triple positive breast cancer, so I'm estrogen receptor positive, and one of the drugs that I take for that is called anastrozole. It's a very common aromatase inhibitor that many breast cancer patients take. So that drug reduces my risk of recurrence by 46%. So just in terms of risk reduction, I want people to understand that a 50% risk reduction in cancer is a huge number that rivals many drugs.
Absolutely. And I would argue, and this is the argument that I used when I first became interested in the preventive powers of sulforaphane or phytochemicals in general. I think we can argue that if we as a community are effective in getting people in general or people specifically to eat more of a certain take more of a certain compound, let's say broccoli, if we have a 1%, if we affect a 1% change in prevention, globally or nationwide, that's still a hell of a lot of lives saved
Yeah,
potentially. So
right.
it's worth, is 50% reduction a good, brass ring to reach for? Sure. But even a small reduction, if it's real, would be immensely satisfying. And again, it's part of the problem with doing prevention research. I'll never know.
Yeah.
Even if I live twice as long as I'm going to live, I'd never know. It's very difficult to quantify.
I do
Um,
have a little case study, though, I will tell you about, which is interesting. So there's a woman named Terry Palastro, and she is a HER2 positive breast cancer patient that I've met. She does a lot of patient advocacy work. But what was interesting to me is I was asking her to tell me about all the things that she does that are, you know, that she thinks helped her longevity because she is over 22 years cancer free, even though she's a metastatic breast cancer patient. So, metastatic breast cancer patient, 22 years cancer free. And I was saying, do you do this? Do you that? One of the things she goes, oh, I don't really do anything. I don't do anything special. But when I started asking her, she does. And one of the things I asked her is, do you eat a lot of broccoli? And she said, oh, I love broccoli. I eat it every day. I'm Italian. I eat it with pasta. But she made a point of saying she eats it every day. She loves broccoli. Anecdotal, I know, but here's someone that I aspire to be, right? I'm 5 years cancer free from my metastatic disease. And so I aspire to her at 22 years. And I thought it was very interesting that she is a big broccoli fan.
Yep. Well, there are a lot of such stories, and yeah, it does your heart good to hear them.
Hmm.
Um, I want to go back to something you said earlier. You mentioned mango, and when we're talking about the taste of broccoli. So interestingly, one of our earlier studies with broccoli sprout or broccoli sprout extract that we made in my lab, um, we were looking for something to pair it with to give to women who were undergoing breast reduction surgery. And the study was going to be looking at biomarkers in the breast tissue that was removed. And this is a study a colleague at Hopkins was doing. A number of us, all PhDs with a lot of lab experience, but no experience tasting foods critically, we had a conference room table and spread out a whole bunch of things and we're mixing and matching. And we decided on mango juice. And so she used mango juice in her trial. And this was an American trial. These were American women and they loved it as a
Oh,
masking agent for, yeah. But then in one of our first trials in China, I guess it was our first trial in China, we went there with mango juice. Wow, people love it. Love even people who don't like broccoli, like with mango juice. Immediately, people are turning up their nose. It I think it led to a problem with recruitment. They hated it. It was too sweet,
I was going to say different
cultural
flavor
attitude.
profiles.
It was too sweet, too sweet. So we modified things. In the next trials we did, we found that pineapple juice with a little bit of lime juice actually was a great masking agent that worked in China.
Okay.
Um, because you have to have just the juice, the stuff available as a control, because this was a controlled experiment.
Sure.
So anyway, so when you make your smoothies, maybe you want to put a little pineapple in. I don't know.
Yeah, that sounds like some good advice. Some good advice. So, I know that you've done a lot of research with sulforaphane and looking at um, what happens um, with cancer cells. Can you talk a little bit about sulforaphane's ability to inhibit metastasis? Because I know that a lot of doctors will say nobody dies from cancer, they die from cancer metastasis. And if cancer never metastasized, we wouldn't really have a problem. We can cut it out, we can radiate it, we can do things to manage a spot of cancer when it's local. It's when it is not local that it becomes a really big problem. So, does it have any impact on metastasis?
Um, I, I believe the answer is yes. I cannot cite you clinical studies that prove that, but we know in animal models and cell cultures, I mean, some of the needle movers, if you will, on the anti-cancer effect, in addition to NRF2, which I want to come back to, but the HIF1 hypoxia-inducible factor, which helps cancer survive in hypoxic environments. Um, by promoting blood vessel growth and which is also called angiogenesis. So sulforaphane inhibits this HIF1. Sulforaphane inhibits HDAC or histone deacetylation. Has to do with opening the chromatin structure and allowing enhanced gene expression. So there are effects of sulforaphane on MMPs or metalloprotein matrix proteins. It downregulates some of the key such proteins that are very much involved in metastases. A lot of these proteins have to do with the cell-to-cell contact and the adhesion of cells. Um, so and I mentioned that the NRF2. There is a concern that's been articulated about upregulating NRF2 if you have active cancer. What I've been led to understand, what I know is true, is that the number of cancers that actually have a mutation in, it's called KEAP1, it's a chaperone protein for NRF2. Too much information, I know, but the number of cancers that have that mutation, which allows NRF2 to become constitutively activated, is probably only about 1%. So, there was a question of, well, if you've got really active NRF2, is that protective for the cancer cells? And it probably is. I mean, I'd say almost certainly it is. However, even in those cases, adding sulforaphane is not going to move the needle, because if NRF2 is upregulated constitutively, there's going to be so much of its upregulation that adding sulforaphane in the diet or the supplements isn't going to have an effect. So, I mean, I think, and sulforaphane is selectively active against cancer stem cells. And cancer,
Okay.
in fact, we've just done a paper looking at synergies between sulforaphane and other compounds, drugs and phytochemicals. And these cancer stem cells are, I think most people, considered sort of the root of cancers and the persistence of cancers after therapy and causing relapses by initiating new tumors, metastases. So they're crucial targets for new cancer therapies. Most conventional chemotherapeutic agents can't target these cancer stem cells once they enter a quiescent state. Once they stop, because I should back up and say these cancer stem cells can be very active and do their damage, cause metastases, but they can also remain quiescent. It's sort of like what happens with HIV. You have maintenance levels that are in your body someplace, and unless you get rid of every last one, you're not in the clear. But
So
this
quiescent meaning dormant or
meaning
sleeping. So not
sleeping. Yeah.
active, just kind of present, but not causing anyone trouble. And so
Yep.
they can lie there and wait for long periods of time.
Yep. Exactly. So a lot of the conventional chemotherapeutics that are highly cytotoxic but their focus is on highly dividing cells. So they're not going to touch, theoretically, as far as I know, the quiescent or dormant or sleeping cancer stem cells. And since sulforaphane inhibits the self-renewal of those cancer stem cells and their proliferation by modulating some key pathways and effectively reducing cancer stemness, as it's called in the literature, across various cancers, breast, lung, prostate, bladder, I think.
Mhm.
It can be effective where some of these other conventional chemotherapies aren't cannot be expected to be.
You just said so much amazing stuff that I want to break it down a little bit because there's a lot there. So, first, you were talking about the fact that we don't have evidence to say that sulforaphane specifically inhibits metastasis. But what we do understand are the pathways that cancer uses to metastasize are indeed pathways that sulforaphane impacts in a positive way. So you mentioned what some of those pathways were. I just want cancer patients out there to understand. You may not know all of these terms, but the longer that you lean into this research, you'll start to hear some recurring pathways that are common for cancer. And Jed, you were talking about several of those. So we can't say it inhibits metastasis directly. We don't have that research yet, is my understanding, but we do know the pathways it impacts, and we do see that association. Is that right?
Correct. Correct. Um, there may well be, in fact, I think there probably are some studies looking at the impacts of sulforaphane on metastases in an animal model.
Okay.
I can't summon it to mind right now, so I don't want to say there are, but not in people.
Okay.
Um, but yes, the pathways that are impacted, and especially as it relates to cancer stem cells, absolutely all signs are very positive.
So, also for cancer patients to understand, a lot of cancer patients might have an initial localized cancer. I myself had a stage 0, sometimes called DCIS breast cancer, that was super early stage, and I had surgery to remove it. And they told me, you know, I was essentially cured. There was a less than 1% chance that it would return to go off and live my life, which I did. And 13 years later, I was diagnosed metastatic. So, in those 13 years, what the scientists believe is that there were cancer stem cells from my initial cancer that were lying dormant, that weren't bothering anyone or doing anything. They were moving very slowly or not at all, just sleeping. And then something woke them up. And when that happened, the cancer spread, and then I was diagnosed with stage 4. So when you talk about cancer stem cells, these dormant or sleeping cells, it is important if we do have a tool to help mitigate that or get rid of those cells, because that is such a threat to our longevity as someone who's had cancer. So you're saying that sulforaphane affects the pathways or affects cancer stem cells and may affect their ability to progress. Is that true?
Yes, 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 absolutely. And again, this is the result of many preclinical studies, but I mean, there are, uh, I was just looking while you were talking, apologies for double trying to, uh,
That's
but
okay. We appreciate it.
the titles of some recent papers in the last 3 or 4 years. Sulforaphane, an emergent anti-cancer stem cell agent. Sulforaphane suppresses bladder cancer metastases. Uh, Another one, sulforaphane suppresses metastasis of triple negative breast cancer. Now these are, I haven't opened them. Well, this one's in Nature. This may be um, It's not it's not a clinical study. It's a preclinical, but there's a lot out there. Yeah, and I mentioned a number of different pathways, and certainly any of these papers probably will talk about them. I mean, I mentioned what did I mention? NRF2,
Yeah.
HIF1, the HDAC epigenetic sequence, MMPs, which are involved in cell adhesion and migration. Um, VEGF is a target that sulforaphane leads to decreased expression of VEGF in these
Mhm.
cancer cells. Um, and yeah, so the Wnt beta catenin sequence, hedgehog, NF kappa B, which is a major inflammatory pathway. So yeah, again, it can sound like it's a panacea, but if you list all the genes that are affected, it is quite impressive.
You're hitting a lot of the key things that we need to be hitting if we're going to try to beat cancer. I do
Yeah,
want to also go back to one thing that you said earlier because it's the one thing that has uh, that is kind of almost a cautionary note. And so while we're showing all of these positive things that sulforaphane can do for us, there is one thing that patients need to be aware of. If you have a mutation in KEAP1, and the number of people who have a mutation in KEAP1 is very low, so like less than 1% of all cancers. But if you do have a mutation in KEAP1, then is it possible that sulforaphane may not be a good choice for you?
those who have a mutation in the NRF2 pathway have constitutively upregulated or overturning NRF2, and probably far over and above what could be achieved by dietary or supplement means. So I think caution is necessary with any supplements, including sulforaphane. Do I think you should talk to your physician before adopting a supplement regime if you have active cancer? Yes. Am I disappointed and sad that more physicians don't know more about diet and cancer? Oh yeah.
Oh, yeah.
Very sad about that.
Hmm.
So asking your physician many times, and look, I'm not dissing the medical profession, but asking your physician many times about a dietary approach or a supplement approach, you're going to get a knee-jerk reflexive reaction. No, it could be dangerous. It could be
Right.
bad.
Yeah, I've
Um,
experienced that.
I'm sure you have, and so you can argue that a supplement approach could be bad because yeah, if you get lousy supplements that were made without quality control and third-party checks, you might be taking something that's contaminated and on and on and on. But what I'm sad about is that physicians don't know more about the modes of action of handfuls of phytochemicals. There are
Right.
dozens of them that are of interest here, and even less about the effects of dietary approaches where you're getting this wonderful cocktail of preventive, protective
Right.
foods in whole foods. Yes,
Well,
you should think carefully about any supplement strategy, but
mhm.
I think the risk, I mean, look, if you go back to the dietary epidemiology, the fact that people who ate more broccoli and eat more broccoli get less cancers, that's a big deal, I think.
It's a big deal.
And that's all we're talking about when we're talking about supplementing or dietary approaches.
No, I think I'm finally understanding something, which was what you were saying about the Keep One and the NRF2. I think I was missing this before. So what you're saying is this very small number of people who have this mutation in NRF2, it's a mutation where NRF2 is already upregulated, meaning it's already, for some reason, in the tumor microenvironment or in your body, your NRF2 pathway is going double time or triple time or quadruple time. And so it's upregulated. And
Yeah,
so
that's right.
the
Yeah,
cancer, yeah.
Yeah.
Yeah, in the
Yep.
cancer. So you're saying that if, is there some concern that adding sulforaphane, which already enhances NRF2, could maybe be more fuel on the fire? But you're saying that, you know what, the fire's raging so big that, adding a little NRF2 from broccoli sprouts is probably not going to be enough to make a difference one way or another. Am I understanding that correctly?
Yeah, there's another reason I brought it up because back many years ago now, when people first started looking at these upregulated NRF2 tumors, and this was there. So this is, yet again another mouse experiment where someone was able to cause a mutation in the NRF2 pathway and have this mouse constitutively producing NRF2, churning out a lot. It was a disaster. And so the concept that, wow, you don't want to upregulate NRF2 in a cancer situation because it's a disaster. I mean, that scenario was discussed in the literature by some very high quality scientists. And so it got a lot of people saying, "Oh, geez, if you have cancer, you don't want to upregulate your NRF2." We don't think that's the case. Many years of additional research have I think underlined that. But it is a concern that was discussed in the literature 10, 15 years ago, 20, maybe even 20 years ago. So this gets back to going to your physician for a recommendation
Mm-hmm.
on supplementation or
Yeah.
diet. Well, many of them, of course, go to their drug book in the pocket of their lab coat. But if some of them have had education on diet and phytochemicals, they may have been made aware of these papers, these discussions. Things have changed since then,
Mm-hmm.
in terms of the sort of consensus, scientific consensus.
It's interesting because I see there's a lot of frustration from cancer patients that they read something and it appears to contradict itself, right? Like, so, two different studies seem to have completely polar opposite views of something. What I've learned over 5 years as a patient reading a ton of research is that the answer is often yes, meaning both can be true. In the gut microbiome, we know that if you don't have akkermansia, which is found in the gut microbiome, it could inhibit the ability for immunotherapy drugs to work as well as they should, or even work at all. But if you already have akkermansia and you supplement for it and you have this massive dose of akkermansia now in your gut microbiome, that could be negative. So sometimes it's not binary, right? And maybe having the broccoli sprouts impact on NRF2 can be a positive thing. It can still be a negative thing if you have a mutation that's causing these massive, upregulation of NRF2. And I'm just theorizing based on other research in other categories that I've done. But I just want patients to understand that as much as we'd like things to be black and white and to be yes or no, that a lot of this stuff doesn't work that way. And you really have to pay attention to moderation and sensible thinking, I'm going to say,
Yep.
and measurement. The more you measure your body, the more you understand what your body is doing, the better you're armed to make good decisions about how you can influence your biochemistry to optimize it for your own experience. So I just wanted to give a little bit of backstory on that, Jed, because I think it can get very confusing.
It absolutely can and does. And you brought up the reversal of sort of common wisdom that happens in all science, really. This is the nature of the beast. I mean, no one person or group can give you the definitive answer on just about any subject for all time. And so people have their own little piece of research. Many of us in the sciences, we have great expertise in one very, very small slice of the whole pie, right? And so we publish on that.
Hmm.
And over time, if that idea or that research has legs, other people do similar studies and confirm it, confirm what you said, or not.
Yeah.
And importantly, sometimes not. And so the consensus evolves over time. You know, you'll see all sorts of,
Hmm.
in fact, the literature is, I think, plagued with review articles now, and I'm guilty of that too, since I stopped having a lab to play in. But you know, you sort of look to review articles to assimilate the information that's out there. And then, you know, as things progress in the sciences and especially in cancer research, then you go to, you start to see clinical trials, not just animal trials.
Hmm.
And then, you know, you may see small clinical trials. We've done many of them. And then you may see larger randomized controlled trials. And then after a number of randomized controlled trials have been done, you start to see meta-analyses, which is people taking um, various trials that have been done in slightly different ways and trying to make sense of them and come up with a consensus number
Yeah.
statistically. So
So,
yeah, it's always an
let's
evolution.
wrap that thought up in, the evolution of where we are right now for sulforaphane. Because ultimately, every cancer patient's going to be thinking to themselves, is this something I want to do or not? Should I be eating broccoli sprouts or not? And we're, I believe, in a point in time where the strength of evidence is there to suggest its benefit in general, as a food, especially. Is that true?
Yes. Period.
Period.
Yes. Yeah.
Yes.
Yeah.
And I know that you have studied a lot, not just sulforaphane in itself, because, oftentimes, well, I'll just back right up and say, when I was looking at my own diagnosis and what I was going to do about it, I went back to thinking about the 1960s when they started experimenting with layering cancer drugs. So not just using one drug at a time, but two at a time or three at a time, and how they found a benefit when they were stacking those drugs and they could affect more than one cancer pathway at a time. You could shut down more all at the same time, and then they had better result. So I started thinking about that for myself and was thinking, gee, what if I was to layer on other strategies too? So, what if I improved my diet? What if I improved exercise? What if I did all these various things that I could do to try to make myself as immune as possible to cancer metastasis and recurrence? Um, what do we know about layering sulforaphane with current cancer drugs? Does it work synergistically? Can it benefit us in conjunction with some drugs?
Well, I just actually submitted last Friday for publication a paper entitled Sulforaphane Synergies with Phytochemicals and Pharmaceuticals, Implications for Health Span. So we have a table of about 75 or 80 synergies that have been shown in laboratory and preclinical studies, animal studies. And indeed, there are very many cancer drugs uh, that sulforaphane synergizes with. And synergy is a term that's been abused or overused, used inappropriately. Synergy is not 1 + 1 = 2. Synergy is 1 + 1 = 3. So some of these papers that we've quoted in our review don't really have real synergy. They have an additive effect. Um, in many of them, it's true synergy where sulforaphane, and sorry, let me back up and say what's important about synergy with pharmaceuticals, with cancer drugs? Well, as we know, cancer drugs, especially the classic cancer chemotherapeutics, can be terribly toxic to the whole body, cause a lot of side effects we don't want to see, you don't want to see. And so if you have true synergy by giving something else like sulforaphane, you can reduce the amount of the toxin, the therapeutic, that's required, and therefore, at least theoretically, have a reduced amount of collateral damage with the same effect on the cancer cells. And so that's one of the reasons, only one of them, that we are so entranced by these synergies. And sulforaphane, we go through this in our review, also has synergies with some other phytochemicals. And how do you view that? You view that as, yeah, that's the reason to eat whole foods. That's the reason to combine onions and broccoli and,
Can you
on and
give
on.
me an example of other phytochemicals that they work synergistically with?
But yeah, quercetin is one. Quercetin from onions, among other things, from soy. Um, those are two very well-known ones and that have a lot of research behind them. Yeah. I'd like to use this question actually to back into something else that you and I have talked about. So what we have is a review of a whole bunch of papers, as I say, 80 or so. I think we have a couple of hundred references in this paper of sulforaphane synergies. Are there any clinical trials in that whole mess? No. So how do you view that? As a patient, does that mean that you should look at the chemotherapy you're getting and maybe eat more sulforaphane? Honestly, I think it might. Should you talk about it with your oncologist? Yes. But it reminds me of some work that we've done with bladder cancer. And we got some really spectacular results with a rat model of bladder cancer with animal models and cell culture. But to this day, there's not a clinical trial looking at sulforaphane and bladder cancer. And the reason is it's very intrusive to do those kinds of trials because you have to do a cystectomy and take samples from the bladder again and again and again and take biopsies. And most people who have bladder cancer have been intervened with so much already that we started a trial and it was impossible to get. I think we had one or two recruits, but it was
Mhm.
impossible to get the number of subjects to continue the study. Attempts haven't been made to repeat it thus far. But what we showed with broccoli sprout extract is a dose-dependent inhibition of multiplicity, of size, and of progression of bladder cancer by giving this sulforaphane orally. And the concentrations of isothiocyanate, so sulforaphane is metabolized into a number of compounds, but the concentrations of all of those compounds together in the bladder, in the urine, was 2 to 3 orders of magnitude higher than those in the plasma or the blood. Um, and the take home there was, yeah, of course, sulforaphane is absorbed by cells, rapidly metabolized, excreted as these various metabolites. When it's excreted, where does it go? Excuse me, not to the hair, not to
Right.
the fingernail. It goes to the bladder and it gets
Right.
voided from the body. So it made so much sense that the epithelial tissues, the inside lining of the bladder, was an ideal place to look for sulforaphane-based cancer prevention. And it works incredibly well in an animal model. But again, so I'm saying
Yeah,
this
so
because,
we need,
what if you're a bladder cancer patient?
yeah.
Should you be taking a sulforaphane supplement or broccoli sprouts? I'd say absolutely, but I can point to zero clinical trial evidence to
Mhm.
support what I said.
That's right. And Jed, I know you're a PhD, not an MD, so we always want people to go talk to their doctors. But I have a few statistics from that work that you did that blew my mind that I just want to replay for some patients. Number one is that cigarette smoking accounts for about 50% of bladder cancer, which I did not know. Other important factors include occupational exposures that are specific to aromatic toxins. So, like breathing in toxins. I'm thinking about nail salons, hair salons. So, just kind of keep that in mind, everyone. And that the risk of recurrence for bladder cancer is about 50 to 60% for grade 1 and grade 2 tumors, and 80% for grade 3 tumors. So, what that means is that if you do get bladder cancer, there's a high percentage of people who actually go on to have an advanced stage of bladder cancer. So here is a potential anti-cancer strategy that is inexpensive. And as Jed was just saying, there's a lot of reasons to think that it will work and that it will get to the bladder to be able to be efficacious. And here is a particular cancer that really could use some extra help, right? That really could benefit.
Yep. Yep. Well
And
put. Well put.
the fact that half of it's from cigarette smoking is kind of interesting to me because one of the things you've talked about is how well sulforaphane detoxifies the body. Is that true?
Yes.
And so, cigarette smoking being toxic, as well as all those, hair salons, nail salons, all breathing in all that toxicity. It's interesting that you chose bladder cancer as a place that you thought had a lot of promise.
Yes, I agree. And back to the point you just made, one of the clinical trials I've been most intimately involved with is the one we did, or is the series of them that we did in China, rural China. And we were looking at the effects of first aflatoxins from food, but then air pollutants. And what we found, among other things, was that benzene, I think pretty much everybody, even if they're not scientists, sort of get that benzene is not something you want to be breathing in. It's a
Mm-hmm.
it's a carcinogen. So, but benzene is present in air pollution, and we found dramatically enhanced levels of benzene conjugates in the urine in study subjects who were on broccoli sprouts, who were taking a broccoli sprout extract. So,
So
and this
that signifies that it's flushing it out of the system then?
exactly. Sorry. Yeah. So these conjugates are not. So it wasn't benzene that was coming out in the urine, and we saw it in the plasma also. It was the detoxification product of benzene and a few other air pollutants also.
Mm-hmm.
And so this was an effect that we saw over a 3-month period. It was stable and it was maintained, um, indicating that the protective effect is not fatigued. It doesn't wear out. And also, it was correlated with the levels of air pollution recorded in that area. They were recorded daily. Now, they weren't monitoring benzene, they were monitoring PM 2.5s, I believe, so or particulate pollution. But it's known that those two go hand in hand. If you have a bad pollution day, you're going to have more benzene as well as more little particles. So, yeah,
So
I
you were able to see a relationship between the air pollution going up, the subjects taking sulforaphane, and then the benzene that was coming out in their urine because the sulforaphane was able to help the body detox it. Wow, that's really amazing. And you know what that makes me think of? You sent me something timely and just that blew my mind, and that was about GLP-1s. And I'm wondering if you could just talk a little bit about that because that has to do with our body's ability to detox as well, and maybe sulforaphane can help.
hugely, hugely. And I don't need to talk about how popular GLP-1 agonists are now in the popular literature. Um, so when you lose weight, let's just say, with the example of GLP-1 agonists, it would be rapid weight loss or relatively rapid weight loss. What happens to the fat? So you've got fat tissue, you're losing it. You don't get globs of fat exiting the body. It doesn't come out as clumps or as whole cells. What happens is that fat gets metabolized. The metabolites go into the bloodstream, free fatty acids or whatever it's metabolized to. I'm not an expert on this, but and it's excreted. Most of it's excreted in the feces in the urine. Um, but the other fact we've got to remember is that fat cells, just by definition, accumulate all sorts of not only heavy metals, but other toxins that prefer a fatty environment to an aqueous environment. Think of olive oil and water, think of oil and gas. Well, the fat is the oil phase, as opposed to the blood, which is the water phase or the urine. So what happens is these toxins have to go someplace. So you're losing all the fat that was storing them. And we're talking about pesticides, we're talking about BPAs, we're talking about forever chemicals, we're talking about all sorts of nasties that you happened to get in your body, and some of them accumulated in fat, and over time, more and more and more. So anyway, they're all leaving the body, and having time through blood circulation to have a very negative effect on the body. But by enhancing your detoxification ability with a supplement of something like sulforaphane, you then protect yourself against some of the downside of losing weight quickly. It's not fully appreciated. We're starting to see people recognize that in the literature, but this is a prime opportunity for for a dietary intervention or supplement intervention with sulforaphane. Absolutely.
That's wild. Yeah. And it is something that is new to the consciousness, right? We haven't had GLP-1s around for that long, but now they got popular really fast. And I've seen people, the pounds just melt off really quickly, and our bodies are meant to detoxify themselves. But when it's moving that quickly, I would imagine that having something like sulforaphane to help the detox could be very beneficial.
This is something where, again, I'm not being too negative about the medical profession, but perhaps our whole system of medicine. When someone has 15 minutes with their doc and they're getting prescribed Ozempic or something like that, is there really time for counseling about diet? And probably they say something about exercise and diet, but this is a case where I think dietitians and nutritionists can play a big role.
Yeah.
Um, I don't know if if prescriptions for GLP-1 inhibitors or agonists are paired with advice to go see a dietitian, but it probably wouldn't hurt. And the nutrition community is aware of this, but probably could be more aware. So
Well, I think, there's been themes that have run through what we've talked about today. We have talked about how the sulforaphane can help detoxify and how that has been picked up in epidemiology research. And now we're talking about how that impacts our bodies and these new drugs and how that can be used with GLP-1s. And we've talked about how there's also positive impact on cancer and how cancer drugs can perhaps work synergistically with sulforaphane to have an even bigger effect, or perhaps same effect with a less dose that would be less harsh on the system. But all of these things need some further research. And I think that we need to rely on clinical trials and try to push on those trials to get us to the end. But I think we have identified some great choices that cancer patients can make immediately in just having broccoli sprouts, let alone supplements, those you can discuss with your doctor, but simply eating broccoli sprouts is a great option that hits on a lot of these positive notes.
completely agree. And I think we have touched on a lot of interesting issues. We can say, and we'll be saying this until we're dead and gone, both of us, we can say that we need more clinical trials. Yes, we do. But I think if I were to be asked what's the most promising area of research on sulforaphane, I actually, having just written this review on synergies, I actually think that synergies with other compounds is really, really, really important. And it's easier to deal with these days because we have the AI and the computational tools to handle these massive amounts of data that can go into examining synergies of not just two, but three, four, five compounds at a time. Because when you talk about eating, you're talking about eating thousands of phytochemicals together. And, in the last 10, 20 years, we're now able to identify them quite well. We're also able to identify the microbiome, the components of our microbiome, and the compounds that they produce. It's called metabolomics. So there's so much information that you really do require high excuse me, high computational capacity to deal with. And we have that now. We didn't have it 5 or 10 years ago. So I think the time is ripe for a real thorough examination of some of these synergies with drugs and other phytochemicals.
Well, it's great. We really appreciate all of your time today and taking us through this. I do think it's exciting. I integrate this myself, and I am going to continue to make those broccoli sprouts and maybe now have a second container on my shelf. But thank you so much, Dr. Fahey, and we really appreciate your time.
Delighted, of course, and happy to come back anytime. We didn't cover a lot of things we wanted to probably, but thanks for your questions. They're very probing, and I'm sure your viewers will enjoy.
And now, an important announcement. All the information that was provided today was for educational purposes only. I'm a patient, just like you. I am not a licensed or accredited physician, therapist, or clinical researcher. All information provided is not intended as a substitute for the advice of a physician, therapist, nutritionist, or any other qualified healthcare professional.